Today topic is a general second order linear differential equation with a constant coefficients. A general second order linear differential equation with a constant coefficient. Is of the form a into d square y by dx square plus b into dy by dx plus cy is equal to f of x. The second order linear differential equation with the constant coefficient is our okay. Number one, the roots of this is a secondary equation. Solving we get two roots. First the roots. Next the complementary function. General solution. CF means a complementary function. Type number 1. Roots are real and equal. Roots are real and equal. Complementary function is ax plus b of e to the power of mx. General solution is y is equal to complementary function. Number 2, roots are real and distinct. Complementary function a e to the power of m1x plus b e to the power of m2x. General solution y is equal to complementary function. Number 3, roots are complex. Complex means is of the form alpha plus I beta. Alpha plus I beta of the form. Complementary function a to the power of alpha x a cos beta x plus b sin beta x. Particular integral y is equal to complementary function. Suppose the right hand side f of x is 0, then the general solution is y is equal to cf only. Suppose f of x is given, then particular integral. Adding particular integral. PI means a particular integral plus PI. This is the structure of the three types of problems. Number 1, real and equal. Number 2, real and distinct. Number 3, complex roots. Okay. Now EX number 4.5. Sum number 1. Solve the following. Differential equation. Number 1, d square by dx square minus 6 dy by dx plus 8y is equal to 0. First we have to find the auxiliary equation. Let d square y by dx square minus 6 dy by dx plus 8y is equal to 0. The auxiliary equation is m square minus 6m plus 8m is equal to 0. Factorizing, we have m square minus 2m minus 4m plus 8 is equal to 0. Take first two terms, m into m minus 2. Take next two terms, m minus 2 is equal to 0. So m minus 2 into m minus 4 is equal to 0. Is equal to 0. M minus 2 is equal to 0 implies m is equal to 0. M minus 4, m is equal to m minus 4 is equal to 0 implies m is equal to 4. The roots are 2, 4, real and distinct. Is a e to the power of m1x plus b e to the power of m2x. In this case, m1 is 2. Therefore, a e to the power of 2x plus b e to the power of 4x. Next, the general solution. Y is equal to CF. In this case, a e to the power of 2x plus b e to the power of 4x. CF only. Why? Right hand side is equal to 0. Therefore, particular integral is 0. Y is equal to CF plus 0. 0 is particular integral. Pi, this is 0. Okay. Next, number 2, d square by dx square minus 4 dy by dx plus 4 is equal to 0. Let d square y by dx square minus 4 dy by dx plus 4 is equal to 0. The auxiliary equation is m square minus 4m plus 4 is equal to 0. This can be written as m minus 2 whole square is equal to 0. M minus 2 into m minus 2 is equal to 0. M minus 2 is equal to 0. M is equal to another m minus 2 is equal to 0. M is equal to, the roots are repeated. Therefore, the complementary function is a x plus b e to the power of mx. In this case, 2x ax plus b of e to the power of 2a. The general equation is the general solution is y is equal to ax plus b e to the power of 2x. Next, question number 3. Solve d square plus 2d plus 3 of y is equal to 0. Let d square plus 2d plus 3 of y is equal to 0. The auxiliary equation is m square minus 2m plus 2m plus 3 is equal to 0. In this case, d square by d x square is d square. D by dx is equal to d. Okay. So the actual equation is this. Now solving, we get a is equal to 1, b is equal to c is equal to 3, m is equal to minus b plus or minus b square minus 4ac divided by 2a. b is 2 minus 2 plus or minus b square is 4 minus 4 into a into c 12 4 into a into 3 divided by 2 into is equal to minus 2 plus or minus root of 4 minus 12 divided by 2. This can be written as minus 2 plus or minus minus 8. In a complex number system, we can write minus 2 plus or minus root of minus 1 into root of 8 divided by 2. This can be written as minus 2 plus or minus a into 2 root 3 divided by 2. Taking common 2 of minus 1 plus or minus I root 3 divided by 2 root 2. Cancelling these 2, we get minus 1 plus or minus I into 2 root 2. This is all from root 2 is beta of the form alpha plus a plus or minus I beta of the form. Okay. Now the complementary function is, the roots are complex. The roots are complex. Therefore the complementary function is a to the power of mx, here alpha x, e to the power of alpha x, a cos beta x plus b sin beta x is equal to alpha is minus 1, e to the power of minus x, a cos root x plus b sin root x, root 2 root 2x plus root 2 of x. The general solution is y is equal to complementary function e to the power of minus x, a cos root x plus b sin root 2x, t square y divided by dx square minus 2k divided by dx plus k square y is equal to let d square y by dx square minus 2k dy by dx plus k square y is equal to 0. The auxiliary equation is m square minus 2km plus k square is equal to k square y. In this case, k square is equal to 0. Now this can be written as m minus k whole square. M minus k whole square is equal to 0. So m minus k into m minus k is equal to 0. This means m is equal to k comma k. The roots are equal. Roots are equal. Therefore, the complementary function is equal to ax plus b of e to the power of mx. The roots are repeated. Therefore, ax plus b e to the power of kx. Next, question number 5. The general solution is ax plus b e to the power of kx. This is y is equal to. Next, question number 5. Minus 2d minus 15 of y is equal to 0, given that dy by dx is equal to 0 and d square y by dx square is equal to 2 when x is equal to 0. Let d square minus 2d minus 5 minus 15 of y is equal to 0. The auxiliary equation is m square minus 2m minus 15 is equal to 0. M square, adding, take two numbers, adding we get minus 2, product gives minus 15. The numbers are minus 5, positive 3. So product is minus 15, adding we get minus 2. So minus 5m plus 2m minus 15 is equal to 0. Next time, take first two terms, m into m minus 5 plus 2 into so 3 into m minus 5 is equal to 0. M minus 5 into m plus 3 is equal to 0. Therefore, m is equal to minus 3 comma m is equal to 5. The roots are real and distinct. The roots are real and distinct. Therefore, the complementary function is a e to the power of mx m1x plus b e to the power of mtx. So is equal to a e to the power of minus dx plus b e to the power of yx. Right hand side is 0. Therefore, the general solution is is y is equal to a to the power of minus 3x plus b to the power of 5x. Next, dy by dx and d square by dx square are given when x is equal to 0. First, differentiate y with respect to x. This is 1. Then dy by dx in equation number 1 is equal to a minus 3 a to the power of minus 3x plus b into 5 a to the power of 5x. This means minus 3a minus 3a a to the power of minus 3x plus 5b a to the power of 5x. Okay. Now dy by dx given dy by dx is equal to 0 when x is equal to 0 is given. Therefore 0 is equal to minus 3a a to the power of 0 plus 5b a to the power of 0. This means 0 is equal to minus 3a plus 5b. This means 3a minus 5b is equal to 0. Number this is 2. Again differentiate y with respect to x in equation number. Again differentiate y with respect to x. We have this in this, we have d square by dx square is equal to minus 3 into minus 3 a to the power of minus 3x plus 5 into a to the power of 5x is equal to 9 a to the power of minus 9a a to the power of minus 3x plus 25 a to the power of 5x when d square by dx square is equal to 0. D square by dx square is given by 2. D square y by dx square is equal to 2 when dx by dy by then x is equal to 0. Therefore 2 is equal to 9 a to the power of 0 plus 25 b here b okay 25b a to the power of 0 is equal to 9a plus 9a into 1 plus 25b into 1, so is equal to 9a plus 25b. So this will imply 9a plus 25b is equal to positive 2. Number is as 3. 2 multiplied by 5 implies equation number 2 15a minus 25b is equal to 0. Equation number 3 multiplied by 1 implies 9a plus 25b is equal to 2. Adding, we get 24a is equal to 2. A is equal to 1 by 12. Substitute A is equal to 1 by 12. Again, substitute A is equal to 1 divided by 12. In equation number 2 we have 9 into 1 by 12 plus 25b is equal to 2. 25b is equal to 2 minus 9 by 12. 9 by 12 means 2 minus 3 by 4 is equal to 8 minus 3 divided by 4. 8 minus 3 divided by is equal to 5 by 4. Left hand side 25b. Now b is equal to 5 divided by 25 into 4. This can be written as 1 by 20. So b is 1 by 20. Substitute AB. Substitute the value of a and b in equation number 1. We have y is equal to a is 1 by 12 a to the power of minus 3x plus b is 1 by 20 a to the power of 5x. Hence the result. 4d square plus 4d minus 3 6 half y is equal to 0. Let 4d square is equal to right hand side e to the power of 2x. Okay. 4d square plus 4d minus 3 half y is equal to e to the power of 2x. The auxiliary equation is, this is type number 2. The auxiliary equation is m square, no, 4m square plus 4m minus 3 is equal to 0. Adding 4, product gives minus 12. Adding 4, product gives minus 12. Number is 6, comma, minus 2. Adding these two numbers, we get 4, product gives. So 4m square plus 6m minus 2m minus 3 is equal to 0. Common 2m. Take first two terms, common 2m. So remaining 2m plus 3. Take next two terms, minus 1 is common. 2m plus 3 is equal to 0. So 2m plus 3 of 2m minus 1 is equal to 0. 2m minus 1 is equal to 0 implies m is equal to 1 by 2. Next 2m plus 3 is equal to 0 implies m is equal to minus 3 divided by 2. The roots are here and there. These two. The roots are real and distinct. Therefore, the complementary function is a to the power of m1x plus b to the power of m3x. In this case, a to the power of minus 3 by 2x plus b a to the power of 1 by 2 of x. Now, the particular integral is right hand side is given. In this case, right hand side is given, therefore type number 2. Right hand side is a to the power of 3x. So, the particular integral. Pi means particular integral. Is equal to a to the power of 2x divided by 4d square plus 4d minus 3. Now, exponential function is given. Numerator exponential function e to the power of 2x. Coefficient of x is 2. Coefficient of x is 2. Take 2. Apply d into 2 or 2 in d. Is equal to e to the power of 2x divided by 4 into 2 square plus 4 into 2 minus 3 is equal to e to the power of 2x divided by 4 4 4 are 16 plus 8 minus 3. 16 plus 8 minus 3. So 24 minus 3. 24 minus 3 is equal to e to the power of 2x divided by 21 is particular integral. General solution is y is equal to complementary function plus a particular integral. Y is equal to complementary function is a e to the power of minus 3 by 2x plus b e to the power of x divided by 2 plus the particular integral e to the power of 2x divided by 21. This is required answer. D square by dx square plus 16y is equal to 0. Let d square y by dx square plus 16y is equal to 0. The auxiliary equation is m square plus 16m is equal to 0. M square is equal to minus 16. Here 16 minus 16 is equal to 0. M square is equal to minus 16. M is equal to m square minus 16. M square is equal to m square minus plus m square plus 16 is equal to 0. M square is equal to minus 16. M is equal to root of minus 16. This can be written as root of minus 1 into root of 16. Root of 16 is 4. I into 4. This can be written as in a complex number system 0 plus I into 4. Here alpha, here beta. Alpha plus I b beta. Alpha plus I beta form. Okay. Now m is equal to, the roots are complex number. The roots are complex numbers. A is 0, alpha is 0, beta is 4. So the complementary function is e to the power of alpha x a cos beta x plus b sin beta x e to the power of 0 a cos 4x plus b sin 4x e to the power of 0x is e to the power of 0. E to the power of 0 is 1. So 1 dot a cos 4x plus b sin 4x is equal to a cos 4x plus b sin 4x is complementary function. The general solution is y is equal to a cos 4x plus b sin 4x answer is this is type number 1. Fraction sum number 8 d square minus 3d plus 2 of y is equal to d to the power of 3x, which shall vanish for x equal to 0 and for x equal to log 2, let d square minus 3d plus 2 of y is equal to d to the power of 3x. Right answer is given. Therefore he wants to find a particular integral. The auxiliary equation is dm square minus 3m plus 2 is equal to 0. M square minus 2m minus m plus 2 is equal to 0. Adding minus 3, product gives 2. The numbers are adding minus 3. So minus 2 comma minus 1. Adding these two numbers minus 3, product gives minus 2 into minus 1 is positive 2. Okay. Take first terms m into m minus 2 minus 1 into m minus 2 is equal to 0. So m minus 2 into m minus 1 is equal to 0. M is equal to m minus 2 is equal to 0 implies m is equal to m minus 1 is equal to 0 implies m is equal to 1. In this case m is equal to 1 comma 2. The roots are real and distinct. The roots are real and distinct. So the complementary function is a to the power of m1x plus b to the power of m2x. Take any one as m1, another one as m2. So a to the power of x 1x plus b to the power of 2x. This can be written as a to the power of x plus b to the power of 2x. This is complementary function. Next, the right hand side is given, therefore we have to take the particular integral t2. This is so t is equal to a to the power of 3x divided by d square minus 2d minus 3d plus 2. Now apply d 3 into d. We have a to the power of 3x divided by 3 square minus 3 into 3 plus 2 is equal to a to the power of 3x divided by 9 minus 9 plus 2 is equal to a to the power of 3x divided by 2 is particular. The general solution is y is equal to complementary function plus in this case particular integral. Y is equal to a to the power of x plus t to the power of 2x plus the particular integral is a to the power of 3x divided by 2. This is the required general solution. And the given is x equal to 0 when x equal to log 2. Okay, x equal to log 2. So this is equation number 1 given. When x is equal to 0, y is equal to 0. Substitute x equal to 0, y is equal to 0 in the above equation 1. We have 0 is equal to a to the power of 0 plus b a to the power of 0 plus e to the power of 0 divided by 2. Since e to the power of 0 is 1, therefore 0 is equal to a plus b plus 1 by 2. This can be written as a plus b is equal to minus 1 by 2. Number this as 2. Next, given when x equal to log 2 and y is equal to 0. So equation number 1 becomes in 1 we have 0 is equal to x is a to the power of log 2 plus b to the power of 2 log 2 plus a to the power of 3 log 2 divided by 2. A to the power of log 2 is 2. Therefore 0 is equal to a into 2 plus b e to the power of log 4 by the power log. 2 log 2 means a log 2 square plus e to the power of log in this case 3 log in 2 to the power of 3. 2 to the power of 3 is by the power law 2 to the power of 3, so 8 by 2 is equal to 2a plus e to the power of log 4 is 4, so 4b plus e to the power of log 8 is 8 by 2, 8 by 2 is 4 is equal to 2a plus 4b plus 4. Now 2a plus 4b is equal to minus 4. Divided by 2 on both sides we have a plus b, a plus 2b. A plus b is equal to minus 2. Number this is 3. Solving equation number 2 and 3 we have n. So equation number 1 into 1. No, equation number 2 into 1 implies a plus b is equal to minus 1 by 2. Equation number 3 multiplied by 1 implies a plus 2b is equal to minus 2. Subtraction is an operation. A minus a is 0. A minus 2b minus b is equal to minus of a plus 2 is equal to 3 by 2. So minus b is equal to 3 by 2. B is minus 3 divided by 2. Next, the general solution is now apply this into equation number 1. Substitute a is equal to 1 by 2. No, a is equal to, find the answer. Substitute b is equal to minus 3 by 2 in equation number 1 or 2 or 2. Equation number 2. We have a plus minus 3 by 2 is equal to minus 1 by 2. Now a is equal to 1 by 2 minus 1 by 2 plus 3 by 2 is equal to 1. A is equal to 1. A is equal to 1. B is equal to minus 3 by 2. Substitute. A is equal to 1. B is equal to minus 3 divided by 2 in equation number 1 we have y is equal to a is 1 into e to the power of x plus minus 3 by 2 e to the power of 2x plus e to the power of 3x divided by 2. This means y is equal to e to the power of x minus 3 by 2 e to the power of 2x plus e to the power of 3x divided by 2. This is the required general equation. This is the required general equation. Next, sum number 9. Solve d square minus d square plus d minus 6 of y is equal to e to the power of 2x plus e to the power of minus 3x. E to the power of 3x plus e to the power of minus 3x. Let d square plus d minus 6 of y is equal to e to the power of 3x plus e to the power of minus 3x. Right hand side two parts. One is e to the power of 3x, another one is e to the power of minus 3x. So we want to find particular number 1 and particular integral number 2, pi1 and pi2. Now the auxiliary equation is auxiliary equations. M square plus M minus 6 is equal to 0. Take two numbers, adding 1, product gives minus 6. The numbers are minus 3. No, the numbers are plus 3 minus 2. 3 comma 2. Adding these two. No, the numbers are 3 minus 2. Adding these two numbers, we get 1. 3 comma minus 2. Product gives minus 6. So M square plus 3M minus 2M minus 6 is equal to 0. M into M plus 3 minus 2 into M plus 3 is equal to 0. M plus 3 into M minus 2 is equal to 0. This means M plus 3 is equal to 0 implies M is equal to minus 3. Next, M minus 2 is equal to 0 implies M is equal to positive 2. Roots are real and distinct. The roots are real and distinct. A to the power of minus 3x plus B e to the power of 2x. See here. Next, the particular integral one. Pi1. Pi1 is equal to e to the power of 3x divided by d square plus d minus 6. This is exponential series. Coefficient of x term is 3. Apply 3 in d. E to the power of 3x divided by 3 square plus 3 minus 6 is equal to e to the power of 3x divided by 9 plus 3 is 12. 12 minus 6 is 6. Is equal to e to the power of 3x divided by 6 is Pi1. Next, Pi2. Particular integral 2 e to the power of minus 3x divided by d square plus d minus 6. Now apply the coefficient of x term minus 3 in d. We have e to the power of minus 3x divided by minus 3 whole square plus of minus 3 minus 6. This means e to the power of minus 3x divided by positive 9 minus negative 9 is equal to e to the power of minus 3x divided by 0 form. 0 form. Therefore, multiply x into e to the power of minus 3x divided by the given d square plus d minus 6 into first derivative. So, d square differentiate, we have 2d plus d differentiate, we get 1 minus 0. This is very important concept. X e to the power of minus 3x divided by 2d plus 1. Apply coefficient of x term minus 3 in d, we get denominator 0. Denominator 0 means it will be infinity. So the next way of the procedure is multiply x into e to the power of minus 3x divided by the denominator d square plus d minus 6 into first derivative. So d square differentiation 2d. D differentiate with respect to x, we have 1. Constant term 0. So 2d plus 1 is denominator. Very important concept. Okay. E to the power of minus 3x. Now coefficient of x term is minus 3. Apply the denominator. 2 into minus 3 plus 1. We get x e to the power of minus 3x divided by minus 6 plus minus 6 plus 1 is equal to x e to the power of minus 3x divided by minus 5. The general solution is the general solution is y is equal to complementary function plus pi1 plus pi2. Y is equal to complementary function is a to the power of minus 3x plus b a to the power of 2x, b a to the power of 2x. Particular integral 1 is a to the power of 3x divided by 6 plus a to the power of minus 3x divided by minus 5 into x. Okay, so y is equal to a to the power of minus 3x plus b a to the power of 2x plus a to the power of 3x divided by 6 minus x a to the power of minus 3x divided by 5 is the required solution. Next is question number 12. Solve d square plus d minus 14 of y is equal to 13 a to the power of 2x. Let 3d square plus d minus 14 of y is equal to 13 a to the power of 2x. The auxiliary equation is n 3m square plus m minus 14 is equal to 0. Now 3m square minus plus m minus 14, adding, take two numbers, adding we get 1, product gives minus 42, minus 42. The numbers are minus 6 plus 1, no, 6 minus 7, 6 minus 1, no, 7 comma minus 6, adding these two 1, product gives minus 2. So 3m square plus 7m minus 6m minus 14 is equal to 0. M is common, first two terms, 3m plus 7 minus 2 is common, 3m plus 7 is equal to 0. M minus 2 into 3m plus 7 is equal to 0. M minus 2 is equal to 0 implies m is equal to 2. 3m plus 7 is equal to 0 implies m is equal to minus 7 divided by minus 7 divided by 3. The roots are real and distinct. The complementary function is a to the power of m1x plus b a to the power of mtx is equal to a to the power of 2x plus b a to the power of minus 7 by 3 x. Now the particular integral is pi is equal to right hand side 13 e to the power of 2x divided by 3d square plus d minus 14. Now apply the coefficient of x is to 13 e to the power of 2x divided by 3 2 square plus 2 minus 14 is equal to 13 e to the power of 2x divided by 4 3s are 12 minus 12 minus 12 14 3s are no 4 3s are 12 plus 2 14 minus 14, so 14 minus 14 14 minus 14 14 minus 14 is 0. 3 e to the power of 2x divided by 0. Therefore, multiply x into the numerator. 13 e to the power of 2x divided by the denominator. One time differentiation gives 3 into 2d plus d differentiation 1 minus constant term 0 is equal to 13x e to the power of 2x divided by 6d plus 1. Now applying the coefficient of x is 2. So substitute 2 into d. 13x e to the power of 2x divided by 6 2s are 12. 6 into 2 plus 1 is equal to 13x e to the power of 2x divided by 13. Cancelling these two, we get x e to the power of 2x. The general solutions. The general solution is y is equal to CF plus PI. CF is a e to the power of 2x plus b e to the power of minus 7 by 3x plus the particular integral is x e to the power of 2x. Hence the solution. Today homework. EX number 4.5. Sum number 10, 11 and 13. Any doubt, reply the message. Thank you, students.